Hey there folks, this is Andrew Franklin, Department of Psychology, Norfolk State University, and in this presentation I'll be talking about variables, scales of measurement, and research methodology. After viewing and listening to this presentation, I'm hoping that you'll be able to understand the following: why we use statistics, the relevance of statistics, important statistical terms, the various scales of measurement and their relevance, or in other words, why we need various scales of measurement, common symbols used in statistics, and finally, I think it's really important that you're able to differentiate between relationships and experiments as far as research methodology. There are multiple purposes throughout the social and natural sciences for statistics. It's a vital component in scientific testing. Statistics are used to describe, predict, and explain scientific phenomena. Statistics is used by psychologists, anthropologists, and sociologists alike to explore and describe behavior, thoughts, and feelings found in humans. It can also be used to predict the likeliness of an event occurring. For example, statistics are used by meteorologists to predict weather patterns and cloud formations. It can also be used to explain why certain behaviors occur. Just as statistics is used to determine patterns of behavior in the present and future, it can help us understand prior behaviors and reactions to certain stimuli. Statistics are everywhere. In fact, our world would look very different, primitive even, without the use of statistics. It is used to explain, describe, and predict election results. Statistics is used in the marketing and private sector to determine what tactics work to increase the consumption of goods and services. Social networking platforms such as Instagram, Twitter, and Facebook are constantly using statistics to increase users and maximize on profits. One of its more well-known / obvious uses are for sports predictions and gambling. Individual player and team stats can be comprised to not only determine the likely winner of a game, but a projected score for each team as well. Gamblers are constantly using statistical methods to decide when to raise, fold, or call. The casinos themselves use statistics to monitor how much they are likely to take in. Now on to important terms. The first terms that we are going to cover are the case, or the subject, or the participant, the sample and its relation to statistics, population and its relation to the parameter, and finally the variable. It is important to clearly understand these terms because we will be using them for the remainder of the semester. I strongly suggest writing these terms down and studying them and highlighting them in your textbooks. First off, we are going to cover the case, also known as the subject. Although these terms can be used interchangeably, the subject is more likely used to describe a single person. Regardless, the case or subject is one single unit used in the study. For example, let's say we have an experiment that is looking for a cure for cancer. This experiment uses 100 cancer patients as participants in the study, and each individual participant would represent a single case or subject or participant. Next is the sample. This is a group of subjects in a study that are a part of a larger group. In reference to our previous example investigating a cure for cancer, our sample would be all 100 of our cancer participants. The word statistics is synonymous with the sample. When we talk about statistics, we are referring to the number that summarizes the sample. Next, we have the population. Our population is the group in its entirety that a sample is drawn from. In our example, the sample would be our participants who have cancer, and our population would be everyone in the world who has cancer. We select the sample directly from our population. Just as statistic is synonymous to the sample, the parameter is related to our population. The parameter is the number that summarizes a population. Lastly, we have our variable. The variable tends to be the factors that we are measuring or investigating. The variable is a measurement that can vary from one person to another in a sample. An example would be height or weight. These variables differ from person to person. When research and experiments are conducted, it is not very common that we are able to test an entire population. There are often too many subjects or cases to realistically pull from. For this reason, we sample a more manageable number from our population. For example, if you want to sample Chinese Americans to see who they are likely to vote for in the next presidential election, it would be nearly impossible to sample every single Chinese American throughout the United States. For this reason, we want to choose a representative sample of the population to test or survey. Based on this sample, we can make an inference and predict what the entire population may look like. In order to have a non-biased representative sample of our population, we make sure to use random sampling techniques. For example, we would not just survey Chinese Americans on the east coast of the United States because this may produce biased results. We would want to choose our subjects at random to avoid this regional bias. On this slide, I will introduce scales of measurement. Do not worry if you don't fully comprehend each of the individual scales of measurement directly after this slide. I will go into greater detail by defining and providing examples for each scale of measurement in subsequent slides. Scales of measurement are one of the key factors in this type of subject matter. Just as we assign numbers to represent variables such as height, the general idea behind measurements are to assign numbers to the observations of the same variables. When we look at scales of measurement, we are referring to a specific numeric scale that indicates the meaning and value of the actual assigned variable. There are four different types of scales of measurement. They are nominal, ordinal, interval, and ratio. The nominal scale is considered the most basic of the four scales of measurement. The nominal scale simply categorizes or provides a name for items. The ordinal scale takes it one step further by not only categorizing an item, but the category is presented in a rank order format. For example, there is a clear first, second, third, and so on choice. Building upon this, the interval scale has equal intervals between items but does not have an absolute zero. Lastly, we have our ratio scale. There's a strong argument that this is the most complex scale of measurement because items are categorized like the nominal scale. These items can be ranked like the ordinal scale. They have equal intervals like the interval scale, and it has a meaningful zero. This means that there can be nothing of or zero of our item or variable. The following pictures are examples of nominal scaled items. You can think of nominal items basically like a label. Nominal numbers are assigned to represent an item. Items have a label that they are referred to as. It is important to note that these nominal scaled items cannot be placed in a rank order system. Notice that there is no first, second, third, etc. social security number, an assigned jersey number, area code, or roadway. The following are examples of ordinal scaled items. With ordinal scaled items, the number assigned can be ranked. For example, you can rank school performance based on GPA. This is how we determine valedictorian and salutatorian for a graduating class. Although numbers assigned to members of sports teams cannot be ranked, their performance can. Based on the number of annual yards gained by a running back, pass completion percentage by a quarterback, sacks by a defensive lineman, or basket score by an NBA point guard, we can assign a rank to the players. Another example of ordinal scaled items in data collection would be the degree to which someone may agree with a statement. For example, if a question states, "How strongly do you agree with the following statement?" the statement being, "This is the most exciting lecture of all time," a rank can be assigned to each number. And of course, everyone is going to say 11 on a scale of 1 to 10. 10 being it's superb. Interval scale items not only categorize and rank order items, but they also have equal intervals. It's important to note that interval scaled items do not have an absolute zero. For example, temperature, personality assessment values, and SAT scores are all examples of interval scaled items. Each of these values have equal intervals. When we look at temperature, there are even degrees for each one, and there are an even set of points between SAT scores. Not that these examples do not have a zero. For example, if a personality scale looks at a score of conscientiousness or our trait of being careful or vigilant, there is no such thing as having the complete absence of conscientiousness. Same as temperature. Although we can have 0 degrees on a thermostat, 0 degrees does not mean we have the absence of temperature. So absolute zeros are zeros that show up on ways in which we measure variables that indicate that there is an absence of the variable. For these interval scaled items, when 0 shows up, if it shows up, that 0 does not mean the absence of the variable. Lastly, we have ratio scale items. Unlike interval scaled items, ratio scaled items have an absolute 0. For example, 0 pounds truly is the absence of weight. Money and time are other examples of ratio scaled items. For example, there is such a thing as having no money or no time. The number of pictures left on a Polaroid camera and height are additional examples. Next, we will cover the difference between discrete and continuous variables. While discrete variables are categorical and consist of whole numbers, continuous variables cannot be placed into distinct categories and fall anywhere on a scale. Continuous variables are not whole numbers. They can be broken into decimals and are defined by real limits. These real limits are defined by plus or minus half of an observed high score. All right, so I know we're on YouTube, but we're still going to try to simulate some type of problem that you can work through so that you can apply the information that you just processed. Looking at these examples, determine the type of measurement scale. Is it nominal, the scale that simply categorizes items like a jersey number? Is it ordinal, the scale that categorizes and rank orders items like the ranking of the top paid actors? Is it on the interval scale, the scale that categorizes and rank orders items and has equal intervals but does not have an absolute 0? Or is it on the ratio scale, the scale that categorizes and rank orders items, has equal intervals and a 0 that means the absence or none of the thing being measured? Next, I want you to determine if each one is discrete or continuous. Can it be placed into set categories and only consist of whole numbers, or is it on a sliding scale that can be broken down into decimals? Pause the video now and try to work through these examples. All right, I'm getting ready to show the answers in 5, 4, 3, 2, 1. How did you do? If you didn't do so well, pause the video, go back to your course materials, revisit some of your answers, follow up with your instructor, and as Daniel the Tiger says, when he is dressed in his well-knitten red sweater, keep trying, you'll get better. In this slide, I would like to start discussing research methods or different approaches researchers use to answer their research questions using the scientific method. In general, I want you to know that sometimes researchers elect to do a cross-sectional research study, and sometimes they elect to do a longitudinal research study. Cross-sectional research is an assessment of variables at a particular period of time. So if I decided to investigate sleep and mental health, I could do so by getting an idea of what your last night's rest looked like, quantity or hour-wise, and then give you a survey on your mood for today. That would be a cross-sectional design to research. It's a cross-section of time and variables of research interest. Now I could also do a longitudinal study which occurs across time. So I could track your sleep over a month or a year and then explore how various measures of sleep are related to your mood at different points throughout the year. Next up, I want to start differentiating the correlational method and the experimental method to research. Let's start with the correlational method. This is defined as two different variables observed to determine whether there is a relationship between them for each individual. The key word in this definition is relationship. When we examine correlations, we are determining if there is a relationship between two variables. Examples of correlational studies would be examining the relationship between job satisfaction and years of employment, or the relationship between number of jobs and amount of income. When we examine correlations between variables, there are three possibilities that may happen. One, there is no correlation or relationship found between the two variables. Two, there is a positive correlation. Three, there is a negative correlation. A positive correlation happens when both variables move in the same direction. If one increases, the other increases. For example, as a student's study time increases, so does his test average. A positive correlation would also be if one decreases, the other decreases as well. For example, when enrollment at college decreases, the number of teachers decreases. A negative correlation demonstrates a relationship between two variables as well, but while one variable increases, the other decreases, and vice versa. For example, the more books I buy for class, the less money I have in my bank account. As the number of books I have increases, the value on my bank statement decreases. This is a negative correlation. It's vital to remember that correlation does not prove causation. For example, studies have shown that when ice cream sales go up, so does the crime rate. Now, just because there is a correlation does not mean that one causes the other. Does it make sense that ice cream sales cause more crime in an area? Probably not. Sometimes there is a third factor that can help to explain a correlation. For this example, high increases in temperature can cause people to become irritated quicker and crime to break out sooner. It can also cause children to want to buy more ice cream to cool down. So we can never state that the correlation proves the cause. We can only make inferences and really try to use critical thinking to ask ourselves if there are other variables at play to explain the relationships we're seeing. So, before we really get into talking about experiments, let me just pause ever so briefly and talk about operational definitions. The operational definition is the definition of a variable of interest that allows it to be directly measured. First, the operational definition describes a set of operations for measuring a construct. And secondly, it defines the construct in terms of resulting measurements. For example, if we were interested in testing if violent television leads to aggressive play, we need to first find out how to measure the level of aggressive play, maybe through behavioral charts. Then we need to define aggressive play based on the measurements or behaviors found. We do this by conducting an experiment. An experiment is a deliberate manipulation of a variable to see whether corresponding changes in behavior result, allowing the to, so before we get into talking about experiments, I first want to spend some time talking about operational definitions. The operational definition is the definition of a variable of interest that allows it to be directly measured. First, the operational definition describes a set of operations for measuring a construct. Secondly, it defines the construct in terms of resulting measurements. For example, if we were interested in testing if violent television leads to aggressive play, we need to first find out how to measure the level of aggressive play, maybe through behavioral charts. Then we need to define aggressive play based on the measurements or behaviors found. We do this by conducting an experiment. An experiment is a deliberate manipulation of a variable to see whether corresponding changes in behavior result, allowing the determination of a cause and effect relationship. Experiments usually involve comparison of at least two groups. A researcher must exercise control over the research situation to ensure that other extraneous variables do not influence the relationship. Cause and effect relationships need to control for possible fallacies. For example, if we are investigating if violent television increases the risk of aggressive play, we need to control for all other variables. Each participant in each condition needs to have the same amount and type of TV exposure and should be controlled for other factors like diet, extracurricular activities, etc. It's important to rely on theory and previous research when determining levels of the IV. It's also important to try to rely on theory, but keep in mind that all hypotheses do not have to come from theory. Some hypotheses may be more data driven or based on existing research conclusions. In the experiment, we have two essential components, these being the independent variable, also known as the IV, and the dependent variable, also known as the DV. The IV is the variable that is manipulated by the experimenter. To manipulate a variable means to intentionally vary the variable in systematic fashion. For example, if we were to look at a study that is investigating if violent television and movies leads to aggressive play in children, the IV would be the violent television. The dependent variable is what we are actually measuring. In this example, we are interested in looking at the level of aggressive play in children, so aggressive play would be the DV. The DV is the variable in an experiment that represents the measurable response or behavior of the subjects in the experiment. When conducting experiments, every variable should be clearly defined, and researchers should rely on pre-existing, validated, and reliable measures so that variables are properly defined and psychometrically sound. In an experiment, we have two groups, the experimental group and the control group. In our example study, examining the effects of violent television on aggressive play, the experimental group would be the group that will watch television, and the control group will not watch any television. The experimental group are the subjects in an experiment who are subjected to the independent variable, in this case, the violent television, and the control group contains the subjects in an experiment who are not subjected to the independent variable and who may receive a placebo treatment, which is a control for confounding variables or extraneous variables. So when you hear confounding variables, think extraneous variables. They are terms that are used interchangeably. The control group is used as a standard to compare the effects of the condition the experimental group is exposed to. Extraneous variables or confounding variables are variables that can affect the internal validity of a study by providing alternative explanations to an effect. When conducting a study, it is important to control these variables to ensure that the results are based on the factor we are manipulating and nothing else. There are two primary types of extraneous variables. Environmental variables are outside factors like light, time of day, and weather conditions. Participant variables are internal factors or characteristics such as age, gender, intelligence, etc. The factors can all affect the outcome of an experiment. That is where random sampling comes in as well. It helps eliminate some of the extraneous variables by ensuring participants are not selected based on any specific extraneous variables. We can also conduct non-experimental studies. There is not a true IV in a non-experimental study. The independent variable that is used to create different groups of scores is often called the quasi-independent variable. Often what you will see throughout this course is the usage of the IV being used to create groups of scores on certain variables. Sometimes researchers are interested in working with naturally occurring independent variables that cannot be manipulated. Some examples of these are natural disasters, life-threatening diseases, and traumatic events. These would be quasi-independent variables that could still be investigated but not manipulated as they are naturally occurring, and in many cases it would be unethical to try to manipulate such a variable to negatively impact a person. Some of the common issues with quasi-experiments and experiments are attrition threat, regression to the mean, and extraneous or confound variables. I want to end this presentation by briefly highlighting some different sampling approaches. Convenience sampling is simply selecting individuals who are available to participate in a study. Representative sampling is a type of probability sampling in which everyone has an equal chance of being selected to participate. Cluster sampling is when people are already divided into arbitrary groups and individuals are randomly selected from the clusters.